My name's Claudine. I'm a cognitive neuroscience from down in Melbourne, and I'm talking today about wearable technology as a biomarker. Okay, so a few disclaimers. This work is funded through NHMRC, the Murdoch Children's, and a Graham Clark Health Tech Innovation Grant. So the structure of the talk today, I've got 4 sections: the introduction and why wearables are relevant to AS. I'm going to take you through an overview of some main projects that have been going on with a gait analysis wearable called the Physiolog, and this work spans technical studies to clinical studies. I'm also going to introduce some opportunities with a new system that's been built in-house by Australian researchers called the Ataxia Instrumented Measurement System. This was built for Friedreich's ataxia, but it's adaptable to Angelman's. And finally, some preliminary quotes from a qualitative interview study I've been doing with a collaboration with UTS. We're asking parents what they think about wearables and how they might work. Introduction. Wearables are big business. The medical wearable devices market revenue was predicted to be $20.1 billion in 2021. It's predicted to be $83.9 billion in 2026. But when you think of your wearable, most people would be thinking of the watch. But that's just not as far as it goes. There's smart belts that can indicate falls risk through your phone. There's smart glasses that can take photos and videos. There's a whole range. And this might seem a little bit futuristic, like something out of the movie Ready Player One, like those haptic gloves or that biometric suit. But this just isn't true. It's already here. You can buy the haptic suit for $1,600 and you can wear it. So wearables are here and they're ready to be taken and used for the benefit of patients. But what about wearable biomarkers? These are not your traditional consumer health and wellness devices. These are biomarkers. So these are just digital biomarkers, and the digital part is the difference. And they can be used to indicate a specific physiologic state. They're used in clinical practice, and they can be used in therapeutics. They fit into the same sort of categories. You can have a safety digital biomarker, a diagnostic biomarker, a predictive biomarker, and so on. The AS field is clearly onto this, and Actim-IO has already been used in AS trials, in a clinical trial and a large natural history study. And I believe the biomarker that was important was stride velocity 95th percentile. I personally haven't seen or held the device, so I can't really go into it too much, but I would love to talk to the Actim-IO researchers. Please come to me. So why is wearable technology and wearable biomarkers important for people with AS? Number 1, data collection without formal assessments. I don't know about you, but in my experience, assessing motor control in children, any children, and children with neurodevelopmental disorders, the tasks and the formal instructions are really hard. This can be overcome with a wearable. High quality, objective results. A wearable is based on an accelerometer. It's giving you very, very sensitive data about movement. And this can give us the granularity that we need to actually start to unpack the mechanisms of the motor phenotype in AS. Number 3, real-world data. We can get insight into the everyday stuff. Number 4, feasible across all individuals. Wearables will work in a child of any level of severity in any part of the world. Number 6, hybrid and decentralized trials. Wearables are a part of this story. A hybrid and decentralized trial is a trial where data collection takes place either purely at home or at home and in the clinic. This saves money in trials and it can speed up drug development and get the therapeutics to you faster. Now I'm just going to change track and talk about some of the work that we've done. And this is a wearable that I've been working with. It's called the Physiolog Gait Analysis Wearable. As you can see, it's a neat little device that just fits into the top of the shoe. There's a few people involved, and this is a body of work, so I just need to acknowledge the students in the RAs and the collaborators, Dr. Rachel Kennedy and Kate Carroll, that have helped with the data collection. So first, This is a summary of the data that we've collected using this device. 6 kids with Angelman, 11 with Fragile X. These participants, we didn't try for structured assessments. We just went for a walk as natural and as good as we could get to get a sample of their gait. 9 with Prader-Willi, 28 controls. These groups, we could do a little bit more. So we did 3 types of assessments. We did that longer real-world assessment, and that's there in the middle where he's walking along the hallway for about 2 minutes. The structured assessment where we're walking from pole to pole, and we also did some dual tasks with the Prader-Willi group. We also have another control group of 94 typically developing children, and this group did the structured lab setup, and this was instrumental in validating the technology and creating our normative data. So I'm just going to go through this slide quickly because it's pretty much just saying that we put the sensors on typically development adolescents, walked along the gait right mat and looked at the how much in agreement 3 of the parameters were. Substantial to almost perfect for 3 of the main parameters that this device spits out. And for example, one is stride length, so that's the length of the distance from the 1 foot to another foot whilst walking. This one might be a bit more relevant to this crowd. Feasibility in AS. While we got the device on pretty easily, we could take the shoe off and put it in and then put it back on. The assessments were a little bit more unpredictable, as you could imagine. This is the sort of thing that we saw occasionally. Walking well, getting data. Stops, distracted by the window. Walking, getting great data. Running. Angelman kids like to run, don't they? So this is fine. That's what happened. I don't want to interfere with that. I don't want to tell the child to stop, repeat anything, fit into some sort of protocol. We can do it on the other end. But the data is challenging because this is a wearable, so it's picking up every single little movement. But it's okay, we've got a solution. So I think this took me a year, but we've been working on this data processing technique, I guess, with a lot of data, working out how to target in a standardised way, step to step to step, that can find that steady state gait, because that's what we want to analyse. And if we're analysing that gait, we're analysing motor control, not behaviour. It's also cool because this can go into software and standardise outputs from gait analysis assessments. Clinical validity. But if we put this wearable on the child, is it actually telling us anything? Well, actually, it is. So here's some data. This is a radar plot. So here I've put all of the groups together except for the normative group. The periphery is the most variable. So SCV, so for example, look at the stride length CV on the left. That means one step was short, one long, short, long, long, short, long, long, for example. So it's not consistent. So we're finding that the Angelman kids are not as regular with their stepping. And we find that for some of the other variables as well. And that's also a way that you can sort of pick up on ataxia. We also looked at actual heel strike. There's a lot of flat stepping, a reduced stride length, and less time of the foot was spent at that first part. So you might see a lot more time at the front of the foot than at on the heel. So normative data. This is important because gait is a maturing system. It's changing in all individuals. It's not really mature until about the age of 7. And so it's important to collect normative data and plot this against age. As you can see, the blue squares are the Angelman kids, and they are more variable in that stride length. So that's that distance of stepping that I was talking about. There's 25 other parameters we can look at, but I just have to pick one just to keep the story straight. I also looked at Prader-Willi and Fragile X, and Prader-Willi had troubles on a different parameter. So and that's the correlation with the controls, and there was some overlap with Fragile X at a younger age. So that's the gait work. Now I'm going to talk about the ataxia instrumented measurement system. Now I've been very fortunate to do an internship last year with this group of clinicians, neuroscientists, psychologists, and data software engineers. And they've developed this system, which is basically, these are 3D printed devices which have sensors in them, and they can measure movement through the interaction with the object. And there's also a pendant that's worn on the chest. So there's a spoon, a cup, and a pendant. It's connected through a phone, there's an app, and all of that is easy. The hard part is the algorithm, which will spit out basically a score that classifies the movement as ataxic and provide a severity of that ataxia as well. So this is built for Friedreich's ataxia, and you're probably thinking that's not going to work in Angelman syndrome, and I agree. So, as I mentioned, the brain of the system has already been made. The phone's there, the app's there, the 3D printing opportunities. So apparently we can change the outer casing into something else and just change the task. So what we want to do with this sort of technology is we want to build an algorithm that best captures the AS movement impairment, not the Friedreich's ataxia movement impairment. We could change the outer casing to a ball, for example. The pendant might work. So normally this is used in a balance test where the individual must stand still for 30 seconds. That probably won't work, but what we can do is put it on and measure ataxia over time for example, 10 minutes of free play. We probably need to have some kind of clothing or something with pressure sensor over it. But that's just some examples of what can be done. Now, just lastly, some qualitative interviews with parents about wearables. This is an exciting project because we're talking to the parents and we're asking them what they think, which is critical when you're making these sorts of steps. So I'm going to just read out some quotes. We've conducted 3 interviews, 2 with Angelman syndrome and 1 a parent of a child with Prader-Willi. So here's this is sort of reflections on assessment with a wearable. This is a parent of a 6-year-old girl. I think it's one of those things when you have a non-verbal child, it's very difficult to understand how they're feeling. You can have a look at something and kind of think that you're very aware of what's going on, but I think it would be very interesting if there's data that sort of can, I guess, describe more about movement and things like that. We also asked the parents if they could design a wearable, what would it look like? And she said, just something that's not visible to their eye, because I think when you come across lots of kids with disabilities, a lot are quite sensory, and the smallest things can put them off. This is key. Just yesterday, I got the transcript from another interview, a 12-year-old boy with Angelman syndrome. I think he was 6 when he got assessed, though. But she didn't really remember the assessment, so this is more about his life now. But I find this interesting because we are trying to measure movement, and I'm talking to the parents and they're talking about changes in the ground and attention and falls and different things to what we're able to measure. So she said, they are what you call like catastrophic walkers in a way. There is always an accident around the corner, but he has to be moving. So it's probably the balance between safety and just keeping them walking. And much the same sort of story when I asked if we could make a wearable, what it would look like. And obviously something that he couldn't see because he would pull it off. So maybe something in the shoe was suggested. Actually, all 3 parents suggested shoes or socks. So anyway, I want to talk to the parents. So parents, please come and talk to me. I'm keen to hear what you think. So conclusions. Work is progressing with the gait analysis device. We've got a lot of data, and it could be trialled at a bigger scale, so I'm keen to explore options for that. The ataxia instrumented measurement system is promising too, possibly even more promising because this is a device built by researchers and it's not a corporate company. And the most important task is to develop the algorithm that best captures the AS movement impairment. And importantly, the data logger, like the CUP, is modifiable to something else, but we must ensure compliance and feasibility. And of course, interviews, key. They support family interest in wearables, but really I think we need to do them to guide what we do. Acknowledgements, I'd just like to thank the Diagnosis and Development team. Professor Godler will speak in a couple of goes. He's my supervisor and has been for some time, and my main collaborators and the funders, and of course, thank you to all the families that participated in our work.